Behind steel, aluminum is the most widely used industrial metal on the planet. It forms the structural backbone of our electric grids, our automotive supply chains, and the packaging that keeps global food systems moving. Every day, the global value of this metal is negotiated and set at the London Metal Exchange, and right now, the signals coming out of the LME are flashing red. This line chart tracks the global settlement price of aluminum over the last year. That vertical climb represents prices blowing past $3,600 a ton, putting the market on a collision course with a record high of $4,000. But watch what happens when we overlay the actual physical supply. This second collapsing line is the inventory sitting inside LME-registered warehouses. In under 2 years, that global stockpile has dropped by more than 66%. To understand how fast supply is vanishing, we look at a metric called canceled warrants. When a factory needs physical metal, they cancel the warehouse storage warrant to take delivery. Canceled warrants are spiking. It is a direct panic indicator, proving that industrial buyers are pulling physical metal out of the system to hoard it. That panic is fracturing the global market. In Asia, prices are relatively stable, but in the US Midwest and across Europe, buyers are paying massive regional premiums, essentially geographic surcharges, just to secure delivery. Price and inventory are moving in opposite directions. These skyrocketing regional markups signal a structural friction that the global market is no longer able to smooth over. To see where the breakdown starts, you have to trace the supply chain back to the dirt. You cannot smelt aluminum without an intermediate powder called alumina, and you can't make alumina without mining raw bauxite ore. The global choke point for bauxite is Guinea. China alone relies on this single West African nation for 70% of its bauxite supply. Recently, Guinea's military junta enacted a sudden export ban on raw bauxite. Their goal is to force foreign mining companies to build local refining infrastructure inside Guinea rather than shipping the raw dirt overseas. Take a look at how this block graphic breaks down the cost of a finished aluminum ingot. Because of the export ban, alumina prices spiked by 20%. That raw material now consumes over a quarter of the total cost to produce the final metal. Upstream resource nationalism is effectively crushing the profit margins of global smelters. Before the metal is even created, it is already too expensive to simply ramp up production. Once you have the alumina, you reach the physical bottleneck of the midstream process, smelting. Transforming alumina powder into solid aluminum requires an immense amount of continuous baseload electricity, roughly 13 to 14 megawatt-hours for a single ton of metal. This energy intensity has triggered a new turf war. In places like the US and Australia, aluminum smelters are being outbid for local grid power by AI data centers. Tech companies can afford to pay premium rates for electricity. Metal smelters cannot. That leaves the Middle East. The Gulf region controls about 9% of global aluminum supply precisely because they have access to highly advantaged, cheap energy costs. But that region is currently navigating its own crisis. Iranian military strikes on Gulf smelting infrastructure, combined with the closure of maritime routes through the Strait of Hormuz, have physically severed this crucial supply line. The resulting damage leaves the global market facing a projected deficit of 1.4 million tons. Rebuilding physical smelting infrastructure takes years, not weeks. Historically, the market would rely on China to flood the world with excess metal, but China has implemented a strict 45 million ton domestic production cap to manage their own energy grids and meet environmental targets. The global safety valve is shut off. The midstream sector is trapped between domestic power scarcity in the West and foreign missile strikes in the East. There is a hard physical ceiling on how much metal the world can currently produce. At the exact moment the supply chain is failing, the global push for electrification is supercharging demand. The energy transition requires massive amounts of lightweight, conductive materials, making aluminum the strategic successor to copper. The automotive sector is applying the most immediate strain. Electric vehicles require between 25 and 40% more aluminum than gas-powered cars. Manufacturers need up to 310 kilograms of the metal per vehicle just to build the battery housings and hit their range efficiency targets. Simultaneously, the aggressive build-out of massive solar panel farms and upgraded power transmission grids is consuming whatever industrial supply is left. Downstream demand is structurally exploding, completely indifferent to the physical and geopolitical crises suffocating the supply chain. Because this crisis is built on destroyed physical infrastructure and a fixed increase in EV demand, the era of cheap, cyclical aluminum is ending. Major manufacturers across automotive, aerospace, and packaging are abandoning decades of just-in-time supply chain philosophy. Operating with lean inventory is no longer efficient. It is a liability. Out of sheer survival, they are moving to a model of strategic hoarding. Procurement offices are locking in fixed-price forward contracts, negotiating strict caps on regional premiums, and physically stockpiling buffer inventory just to keep their assembly lines running. This timeline illustrates the cost pass-through lag. When raw material costs spike on the left side of the screen, it takes 3 to 12 months for those expenses to work their way through manufacturing contracts and hit the retail price on the right. The panic currently isolated inside factory procurement offices is essentially a ticking clock. The price shock of the aluminum gauntlet is already baked into the supply chain, and the consumer is about to foot the bill.